In this video, we are going to look at the skeletal system and its role in homeostasis and aging. Bone is the body's main calcium reservoir, storing 99% of the body's calcium. One way to maintain the level of calcium in the blood is to control the rates of calcium reabsorption from bone into blood and of calcium deposition from blood into bone. So calcium ions are needed for nerve and muscle functions, as well as blood clotting and several enzymatic reactions. So we need those calcium ions in the blood when we need to produce these reactions and these other functions. Calcium exchange is regulated by hormones, the most important of which is the parathyroid hormone, and this is secreted by the parathyroid glands. This hormone, when it is secreted, increases the blood calcium levels, or the calcium levels in the bloodstream. So this is parathyroid hormone. So an increase in parathyroid hormone increases blood calcium levels. And parathyroid hormone secretion operates by a negative feedback mechanism. Parathyroid hormone also acts on the kidneys to decrease the loss of calcium in the urine so that more is retained in the blood. Parathyroid hormone stimulates the formation of calcitriol as well. Remember, this is the active form of vitamin D. And calcitriol is a hormone that promotes absorption of calcium from foods in the gastrointestinal tract and bringing that calcium into the blood. So both of these actions help to elevate blood calcium levels. So calcitriol works to increase calcium absorption in the intestines, and remember, this is calcium coming from the food that you ingest. So the more calcitriol that you have running through your blood, the more calcium that is going to be absorbed from the food that you eat. Release of calcium from the bone matrix and also retention of calcium by the kidneys are two main ways that blood calcium levels can be increased. So here we have a negative feedback mechanism diagram for calcium levels. So here homeostasis is disrupted by decreasing the blood calcium level by some stimulus. And that will be detected by parathyroid gland cells. So they'll detect that decreased calcium concentration in the blood, and this actually increases production of cyclic AMP, which is a messenger molecule. And this is detected, or I guess it sends the information to the parathyroid hormone, and the parathyroid hormone gene is actually going to be turned on, increasing the release of parathyroid hormone into the bloodstream. And with that increase of parathyroid hormone into the bloodstream, it will be detected by osteoclasts, or receptors on these cells, and receptors in the kidneys will actually interact with the increase of parathyroid hormone. The osteoclasts will actually break down bone and have that calcium reabsorbed back into the bloodstream. And the kidneys also work to retain calcium in the blood by retaining that and by not excreting it into the urine. So both of these responses together will increase the blood calcium level, returning us back to a normal blood calcium level and back to homeostasis. So from when you're born through to adolescence, you have more bone that is produced than is lost during bone remodeling. So in adults, the bone that's created, or the rate that bone is created, is almost equal to the rate that it's destroyed by osteoclasts. And as you get older, the rate of bone breakdown by osteoclasts actually is higher than the rate of bone building. So you're actually going to have a decrease in bone mass because of that as you age. In osteoporosis, this is where bone reabsorption outpaces bone formation. So this is where you're going to have bone mass decreases. So this is another way where you're going to have bone is actually going to be broken down by osteoclasts at a higher rate than it's built up by osteoblasts. And that is going to be the end of chapter 6.